Hello everybody. Now we are going to continue our problem with part 5. Show that f has an inverse function g on minus infinity to plus infinity. As you know, to prove that a function has an inverse, this function should satisfy two conditions. The first condition, it should be strictly increasing or strictly decreasing on its domain. Second, f should be continuous on its domain. Let's check our function f. We have proved in the previous parts that f is strictly increasing on its domain, and f is continuous from minus infinity to plus infinity because fx is equal to 1 minus 2 e power minus x. E power minus x is a continuous function, so f is a continuous function on its domain. These two conditions are satisfied, then f has an inverse f minus 1 and it is denoted by g. Now determine the domain of definition of g. The domain of definition of f minus 1, which is g here, is equal to f of the domain of f itself. As you remark, the domain of f is minus infinity to plus infinity. To find f of this interval, we should move to limit. So I should find the limit of fx as x tends to minus infinity and limit of fx as x tends to plus infinity. Limit of fx as x tends to minus infinity is equal to minus infinity in the previous parts, in the first part. And limit of fx as x tends to plus infinity is equal 1 according to the second part of our problem. So the domain of the inverse function is from minus infinity to 1. Part C, verify that gx is equal to len 2 minus len of 1 minus x. We should verify the following. F o g of x is equal to g o f of x is equal to x, because he is asking me just verify. If I verify this, then I verify that g is the inverse of f. Let's start with the first part. F o g of x, it should be equal to x. Let's start. F o g of x is equal to f of gx. This is gx, which is len 2 minus len of 1 minus x. Now I should substitute this quantity instead of x in the expression of f. So it is equal to 1 minus 2 e power minus bracket len 2 minus len 1 minus x. Expand this bracket by removing this minus. So it will be 1 minus 2 e power len of 1 minus x minus len 2. Now I'm going to use the property of len. E power a minus b is equal to a power a over e power b. So this is equal to e power len 1 minus x is up and down e power len 2. E with len, they cancel each other up, and e with len, they cancel each other down. So the expression will be 1 minus 2 times 1 minus x up and 2 down. Now 2 up and 2 down, they cancel each other. I will get 1 minus bracket 1 minus x, which is x. So f o g of x is equal to x. Let's move to the second part of our equality. G o f of x is equal to g of 1 minus 2 e power minus x. This is the expression of fx. I will substitute it where? Instead of x, where? In the expression of g. So it's equal to len 2 minus len of, here the expression of x. It's 1 minus bracket 1 minus 2 times e power minus x. Remove a bracket by multiplying minus by this bracket. It will be len 2 minus len of 2 times e power minus x. Now I'm going to use the property of len. Len of AB is equal to len A plus len B. So this is equal to len 2 plus len e power minus x. Len e power minus x is minus x. So now expand the bracket, it will be x. Now I proved that f o g of x is equal to x, g o f of x is equal to x. After verifying this equality, this proves that gx is the inverse function of f. Now, let's move to the last part of our problem. Let C prime be the representative curve of G, draw C, the representative curve of F, draw C prime, the representative curve of G, and D, which is the asymptote to C. According to the variation table, F is increasing function from minus infinity to 1. And you know that y is equal to 1 is a horizontal asymptote to C, and it increases from minus infinity to plus infinity, taking into consideration that y equals 1 is a horizontal asymptote. Two particular points, A and B, belongs to the curve C. C passes through A, which is length to 0, and it passes through B, which is 0 minus 1. And they are located here. This is A and this is B. So I can graph our function f. Now, if I want to graph C prime, I should refer to the graph of C, taking the symmetry of C point by point. It's enough for us to take about 2 points. You know that the point A has coordinates length to 0 and B 0 minus 1. But C and C prime should be symmetric with respect to y equals x. So A length to 0 belongs to C, then 0 length 2 belongs to C prime. B 0 minus 1 belongs to C, then minus 1 0 belongs to C prime. So now I know this point and this point. They are two particular points of C prime. Now, you know that y equals 1 is a horizontal asymptote to C. Then x equals 1 will be a vertical asymptote of C prime. And the domain of definition of G, which is the inverse of f, it increases from minus infinity to 1 according to the domain of G. And as f is an increasing function, its inverse also will be an increasing function. But it increases from minus infinity to plus infinity, but taking into consideration that what? X equals 1 is a vertical asymptote. Now I drawn the graph of C prime by symmetry with respect to the graph of C, and y is equal to 1 is a horizontal asymptote to C. So now I drawn C, C prime, and B. Thank you for your listening. Bye bye.